In this video, we're going to look at how to draw dot structures of simple organic molecules that have single bonds. So if I look at the molecular formula CH4, which is methane, and I want to draw a dot structure for the methane molecule, I would go over here to my organic periodic table and find carbon. And I can see carbon is in group 4. Therefore, carbon will have 4 valence electrons. So I can draw carbon with its 4 valence electrons around it like that. Remember from general chemistry, valence electrons are the electrons in the outermost energy level. So carbon has 4 valence electrons in its outermost energy level. Next, I have to think about hydrogen, and hydrogen is in group 1 on the periodic table. Therefore, hydrogen will have 1 valence electron. And so I can go ahead and put a hydrogen in there with 1 valence electron. And I know I have to do that 3 more times. So I keep putting in hydrogens, each with 1 valence electron, so a total of 4 hydrogens. And now I can start connecting my dots. I know that 2 valence electrons equals 1 single covalent bond. So there's a single covalent bond, there's a single covalent bond, and then I have 2 more here. So this is my complete dot structure for methane. Now I can see that carbon is surrounded by 8 electrons here, so we can go ahead and highlight those. So if I'm counting the electrons around carbon, it'd be 2, 4, 6, and 8, like that. And 8 electrons around carbon makes carbon very stable. And if we look at the periodic table, we can see why. So if I look at the second period, I can see that the valence electrons for carbon would be 1, 2, 3, and 4. And to get to 8 electrons, we would go 5, 6, 7, 8. So if carbon is surrounded by 8 electrons, it's like it has the electron configuration of a noble gas, which makes it very stable because all of the orbitals in that energy level are now full. So an octet of electrons is the maximum number of electrons for carbon. If we look at hydrogen, we can see that each hydrogen is surrounded by 2 electrons. And so if I find hydrogen here, hydrogen is in the first energy level, and so here's 1 electron and here's 2 electrons. So in the first energy level, there's only an s orbital, and that s orbital holds a maximum of 2 electrons, and we get to the electron configuration of a noble gas. And so hydrogen is stable with having only 2 electrons around it. Let's look at another dot structure. And let's do one that has nitrogen in it. So if I look at the molecular formula CH3NH2, I'm going to once again start with carbon in the center with its 4 valence electrons around it like that. And I know that there are 3 hydrogens on that carbon, so I can go ahead and put in those 3 hydrogens. Each hydrogen has 1 valence electron like that. And then on the right side, I'm going to think about nitrogen. So I need to find nitrogen on my periodic table. Nitrogen is in group 5. Therefore, nitrogen has 5 valence electrons. I can represent those valence electrons as 1, 2, 3, 4, and 5, like that. And I still have 2 hydrogens to worry about, right? So I still have these 2 hydrogens here. And I can see there's a place for them on the nitrogen. So I can go ahead and put a hydrogen in here and a hydrogen in here and connect the dots. And I have my dot structure. And I can also check on my octet rule. So carbon has an octet. And nitrogen has an octet as well. So let's go ahead and verify that. So there's 2 electrons here, 4, 6, and 8. So nitrogen is in the second period, and so nitrogen is also going to follow the octet rule when you're drawing your dot structures. Let's do one with oxygen next. So if I wanted to draw the dot structure for methanol, methanol is CH3OH. And so once again, I start with carbon with the 4 valence electrons, and I have 3 hydrogens, each one with 1 valence electron like that. And so I can go ahead and put in those 3 hydrogens. Next, I have oxygen. So I need to find oxygen on my organic periodic table, and I can see that oxygen is in group 6 right here. So oxygen is going to have 6 valence electrons around it. So I can go ahead and draw in oxygen. And I can put its 6 valence electrons in 1, 2, 3, 4, 5, and 6, like that. And then I'm going to put in the hydrogen, right? So now I have a hydrogen to worry about, and I know that hydrogen has 1 valence electron, so I can see there's a place for it over here. And once again, I can connect the dots and see all of the single covalent bonds in this molecule. So that's one bond, that's another bond, and then I can see the carbon is bonded to the oxygen, and the oxygen is bonded to this hydrogen as well. Again, we can check our octet rule. So the carbon has 8 electrons around it, and so does the oxygen. So this would be 2 right here, and then 4, and then 6, and then 8. So oxygen is going to follow the octet rule. Now, when you're drawing dot structures, you don't always have to do this step where you're drawing each individual atom and summing all of your valence electrons that way. You can just start drawing it. So, for an example, if I gave you C2H6, which is ethane, another way to do it would just be starting to draw some bonds here. And so I have 2 carbons, and there's a pretty good bet those 2 carbons are going to be connected to each other. And then I have 6 hydrogens. And if I look at what's possible around those carbons, I could put those 6 hydrogens around those 2 carbon atoms like that. And if I do that, I'll have an octet around each carbon atom. So this would be my dot structure for ethane. To double check yourself, you could make sure that your dot structure has the correct number of valence electrons. So if I'm thinking about each carbon having 4 valence electrons, and I have 2 of them, I'm going to get 8 valence electrons from those 2 carbons that I have to represent in my dot structure. Each hydrogen has 1 valence electron, and I have 6 of them, so I need to worry about 6 valence electrons from the hydrogen, so for a total of 14. So when I look at my dot structure, I can check to make sure I have the correct number of valence electrons. I need 14, so let's go ahead and count them. So this would be 2 here, 4, 6, 8, 10, 12, and 14. So I have the correct number of valence electrons represented in my dot structure. I also have an octet of electrons around my carbons, and so this would be the dot structure for ethane.